On April 1st, a critical vulnerability was publicly disclosed in Marimo, a popular open-source Python notebook that developers use to write and run code. 9 hours and 41 minutes later, someone exploited it, not with the sophisticated zero-day chain, not by bypassing multiple layers of security. They just connected to a WebSocket endpoint that had absolutely zero authentication on it, and when they connected, the server handed them a full terminal shell, root access, no password, no token, no questions asked. The attacker didn't waste any time. Within minutes of getting that shell, they started harvesting .env files, SSH keys, and credentials. Everything a developer stores on their machine that you never want anyone else to see. And they got all of it because a Python notebook left its terminal wide open to the entire internet. This is CVE-2026-39987. CISA scored it a 9.3 out of 10 critical. They added it to the known exploited vulnerabilities catalog and gave federal agencies until today, April 11th, to patch. Let me show you exactly how this happened and why it should terrify every developer who runs tools on an open port. If you haven't heard of Marimo, here's the quick version. It's an open source reactive Python notebook. Think Jupyter, but modern. When you change a cell, every cell that depends on it automatically re-executes. It's gained serious traction with data scientists and ML engineers because it solves a lot of the pain points that make Jupyter notebooks unreliable. Hidden state, out-of-order execution, reproducibility issues. Marimo runs as a local web server. You start it from the command line, it opens in your browser, and you write and execute Python code through the web interface. It's designed for interactive development, quick experiments, data exploration, prototyping, the kind of work where you want fast feedback, and you're often running it on your local machine or a cloud VM. And like a lot of developer tools, it includes a built-in terminal, because sometimes you need to run a shell command without leaving the notebook. Install a package, check a file, run a script. The terminal is accessible through a WebSocket endpoint at /terminal/Ws, and that endpoint, in every version of Marimo before .23.0, had no authentication whatsoever. Let me be very precise about what CVE-2026-39987 is, because the simplicity of it is the point. Marimo exposes a WebSocket endpoint at /terminal/Ws. When you connect to it, the server spawns a PTY, a pseudo terminal, and pipes everything you type directly to a system shell. Input goes in, output comes back. It's functionally identical to SSHing into the machine, except there's no SSH key, no password prompt, no authentication check of any kind. This isn't a buffer overflow. It's not a deserialization bug. It's not a timing attack. The endpoint just doesn't check who you are. If you can reach the port that Marimo is running on, you can open a WebSocket connection to /terminal/WS, and you have a shell. That's it. The CVSS score is 9.3, critical, with the attack vector classified as network-based, low complexity, no privileges required, and no user interaction needed. In plain English, anyone on the internet who can reach your Marimo instance owns your machine. Now, you might be thinking, who would expose a development notebook to the internet? The answer is, a lot more people than you'd expect. Cloud VMs with ports open, Docker containers with default networking, development servers with 0.0.0 bindings, tunneling services. Every one of these common development patterns turns a local tool into an internet-facing service, and in Marimo's case, an internet-facing service with an unauthenticated root shell. Here's the timeline that should keep you up at night. The vulnerability was publicly disclosed. No CVE reserved in advance, no coordinated disclosure with a patch ready. Just, here's the bug, in public for everyone to see. And researchers at Endor Labs set up a honeypot to see how fast attackers would find it. 9 hours and 41 minutes. That's how long it took from public disclosure to the first exploitation attempt hitting the honeypot. Not 9 days, not 9 weeks, 9 hours. And the attacker didn't even need a proof of concept exploit. The vulnerability is so simple that anyone who reads the advisory can exploit it in minutes. Open a WebSocket connection, get a shell, done. What did the attacker do once they had access? Exactly what you'd expect. They started enumerating the file system. They grabbed env files where developers store API keys, database credentials, and service tokens. They harvested SSH private keys. They pulled browser credential stores.